This video is to demonstrate how to get a best fit curve from a Logger Pro program after having a set of data already put in. So this is my line data. I got my data from the equation y is equal to 2x. By the way, you can double click on this graph. If you hit graphing options, you can put the title in there, and I would label this title y. This graph is equal to 2x. We say OK, and there you see that that title's clearly labeled on that. I've also already labeled my axes. Okay, so the thing that we want is a best fit line or best fit curve. Just to show you all the options, I'm going to click on the curve fitting, and like I did in the other video, I'll show you that we can pick a cubic or a third order polynomial, and we can try the fit. And here it gives us numbers. Like in Google Sheets it gave us zeros. This gives us numbers for these coefficients. A is 3.3 times 10 to the negative 21. Well, that's a ridiculously small number, and we might as well actually just call it 0. The only coefficient that is not insignificant or not ridiculously small is the b coefficient, which is the coefficient in front of just the x term. So what we'll notice is at this point we would probably go back and say, hey, well, let's try the linear fit. And if we try that, it gives us the 0 intercept, which is fine, and the slope is exactly 2. One last thing that we would want to notice is the correlation is 1, and we talked about that on the other graphing program too, the Google Sheets. If we go back to the cubic, it gives us this value of root mean squared error when we try to fit, and this value is given for things in Logger Pro that are not linear. And this value is a root mean squared error is a number that shows good correlation if it's very small. And like this is just like the coefficients were in those. That's also very small, so that's a very small root mean squared error, which means we have good correlation in this case. So we'll go back to the line, we'll try the fit, we say OK, and here you'll notice that in this case we have the line, which you can actually see traced out, and we have this box that tells us that y equals mx plus b, and then it labels m as a 2 and y as an intercept, and then the correlation is great, and we have no error for a root mean squared error.